Hey everyone, Dr. Cohens here. In this video I'm going to talk about one sample t-tests and independent samples t-tests, how to run those in SPSS and how to write those up. So if you haven't already watched my conceptual t-test video, please take a moment and do that. That goes into more of what is a t-test, what is the purpose of a t-test, what is the underlying calculation of a t-test, all of those things that you need to understand so that you know what is going on with this statistical test. In this video, we will focus on calculating these in SPSS and then writing them up in APA style. So what I have here is an example data set that I've modified from Dr. Andy Fields. So he has a fabulous statistics textbook that is one of my favorites, and he has a lot of kind of fun examples. And so in this data set, he has a couple of different variables. We're going to focus on gender. So gender is our variable that has two levels. One level is female, the other is male. I believe it's 1 and 2. 1 is female, 2 is male. We also have arousal. So in this fictional study, they had folks watch one of a couple different movies, and then they rated their psychological arousal based on that movie. So they rated their psychological arousal as a result of watching that film. So there are a couple of different things we can do here. Remember, this week we're talking about one sample and independent samples t-tests. So let's start with the one sample. So in this situation, we would want to compare a sample mean to a population mean. So we want to know, is our sample different in ratings of arousal than our population parameter? So say, for example, a couple of studies have done this before, and they found that mean arousal levels were 25 on whatever arousal scale we're using here. So we're going to test our sample against this population value of 25 using a one sample t-test. So to do that, well, we have to do a couple of things first. So make sure you read in your textbook about the different assumptions of t-tests. There are a couple of them. These are things you have to make sure are in place before you run the test. So your data has to fit a specific set of rules to be able to conduct this test and know that your data fit. One of those assumptions is normality. So remember, we've been talking about this normal distribution. Everything is based on this normal distribution. If your data does not fit that normal distribution, you can't use these inferential tests. So again, I'm just going to do a quick test here. I'm going to look at skew, and I'm going to look at kurtosis. So remember, we did that in the first few weeks of the course. Showed you what positive skew, negative skew, all of those kinds of things looked like. Here we're going to get an actual test statistic. To do that, I'm going to go to Analyze, Descriptive Statistics, and then Descriptives again. My dependent variable is psychological arousal, so I've already moved that over to my variables box. Under Options, I'm going to, so by default these two will not be checked. I'm going to check kurtosis and skew. Hit continue. I can hit OK again to get those results. Here we see our number of participants, our min, our max, our mean. So we know our mean is 21.28, standard deviation. We can also see our skewness statistic is negative 0.129, kurtosis negative 0.318. Now remember, I gave you criteria for this a couple of weeks ago, so if you don't remember that, which, I mean, you probably don't, I wouldn't, go ahead and jot this down on your notes right now. So if your skew is between -2 and +2, you do not have any violations typically. So you're good to go, your data is approximately normal. So our data, skewness negative 0.129, negative 0.318 is definitely within that -2 to +2 range I'm giving you. So we know we can go ahead and run this data. Now there are more complex ways to look at your data, but for this course, you know, intro statistics, we're doing a one sample, all of those kinds of things, I'm happy to just look at skewness and kurtosis. If you were doing a real world research study, you would want to test in depth all of those different assumptions that your textbook lists. Here we'll focus on normality with independent samples t-tests. We'll go a little bit further than that. But for now, we know that we're good and we can run that independent samples t-test, or one sample, pardon me. So go to Analyze, Compare Means, one sample t-test. So I'm going to reset this. This is what your box will look like when you pull it up. We want to know if the psychological arousal, so we'll move that over, of our sample differs from the population value. So this is the test value we're testing against. I said earlier that was 25. So you'll get this number, typically you'll get it from previous research. So if a bunch of people, gave this arousal rating and you found that the population parameter is 25, you would input that here. So oftentimes it's coming from previous research. You could have some expectation, you could test it against that. So there's some different things you can do here. Here we're going to test our sample against the population mean of 25 and see if these are different. We hit OK, and we get a couple of different boxes here. So we get our descriptive statistics here, so we know our n, we see our mean again, standard deviation, standard error of the mean, and then here we have our t-test statistics. So first up top here you can see the test value 25. That's telling you that is the population parameter we are testing against. So we're testing our sample data against this value of 25. Again, you enter that in, you give that to SPSS so you can change that every time you run a test. Okay, so here we have our t-statistic. So remember in that last video we went through a whole bunch of steps to get to this t-statistic. Remember, it's the difference between groups over the difference within groups, and we get this t-statistic. So here it's negative 2.866. And then we would take that t-statistic, go to that t-table using our degrees of freedom. So here it's 39. So remember, in a one sample t-test, it's going to be your n minus 1. So our n is 40 minus 1, our degrees of freedom are 39. So you could go look in that table and it would give you your rejection region and all of that good stuff. Now, because SPSS is a computer program, it can go a little bit further for you and give you your exact p-value. So with those tables, it's giving you a rejection region, and you just say p is less than 0.05. With computers now, we can say the exact p-value. So this sig two-tailed, that is our p-value. So the question you have to ask yourself at this point, is that p-value, that significance value that they're giving you, is that less than 0.05? So remember, if it's less than 0.05, you can reject your null hypothesis. So in this case, our null, I said we were looking to see if the psychological arousal of our sample is different than the psychological arousal in the population. So our null hypothesis would be that those two arousal levels are the same. So if this number 0.007 is less than 0.05, we can reject the null and provide evidence for our alternative hypothesis. Now, 0.05, 0.007 is in fact less than 0.05. So we can reject the null and we can conclude that there is a difference between our sample levels of arousal and the population levels of arousal. Because we're only dealing with a sample versus the population, we can simply look and say which is higher. So our test value, our population value there is 25. Our sample value is 21. Our sample participants scored lower on ratings of arousal than the population. So we look at the p-value, it's less than 0.05. We know these groups are different. We want to know which one is lower. Our sample is lower on ratings of arousal than the population. How much lower are they? What statistic tells us that? So we need an effect size. There are many versions of effect size. The version I would like for you to use with t-tests is called Cohens D. So if you Google Cohens D calc, you will come up with this Dr. Becker's calculator, and you can enter this information and it will calculate it for you so that you don't have to do that additional calculation. So here I have calculated that using the t-value, negative 2.866, 39 degrees of freedom, we know our Cohens D is 0.917. So you can ignore the sign here. It's a reflection of magnitude, so negative values don't really mean much of anything. If we had swapped, if our population value was lower, it would mean something different. It would be opposite, but it's the degree of difference. So our Cohens D is actually 0.92. You can look that up according to those effect size conventions, and it's a decent sized effect. Okay, so one sample t-test here, comparing our sample mean versus the population mean of 25. Our p-value, our significance value here, is less than 0.05. We know it's a decent sized effect. I'm not using the terminology from the textbook because I don't have it in front of me, but you can look that up on your own. Our next step is to write this up, right? We have a statistically significant result. We have a practically significant result. So the effect size tells us practical significance. So we need to write this up in APA style. So here I have an example write-up for you. Let's zoom in on that a little bit. So the first thing you want to do, so these results sections are very formulaic, meaning there's a pattern that you need to follow, right? So the first thing you need to do is say which test you did and why you did it. So a one sample t-test was run to determine whether arousal scores, so remember we're looking at psychological arousal, scores were different than the population arousal score. In parentheses I have mu equals 25. So this is our population parameter that we're testing against. Here I write up arousal scores were normally distributed, and I give our skew and our kurtosis statistic from earlier, and there were no outliers in the data as assessed by inspection of a box plot. Now I didn't actually do that in this video. Remember we did that in the first few weeks. You want to look at your box and whisker, see if there are any outliers, and then decide how to deal with those. Next you report the results from your t-test. So sample arousal scores, parentheses, mean equals, to 2 decimal places, standard deviation to 2 decimal places. Notice our statistical symbols, our M, our SD, our T down here, our P, our D here are all italicized. Also notice it is M space equals space, then your statistic, comma, space. So pay close attention to these spacings. Result sections can get kind of difficult to read, so we want to try to make it as easy on the eyes as possible. So sample arousal scores, mean, standard deviation, and parentheses were lower than the population score of 25.0. And then you give all of your statistics, your t-test statistics. So you do T, and parentheses your degrees of freedom, that is 39, equals your T statistic, so it's negative 2.87, comma, P equals, in all cases, almost all cases, report the exact P statistic here. So give that exact P value. The one exception would be if, let's see, if your P value, so I'm just going to go over here, 0.001, sorry, I can't type today. If SPSS is reporting your P value as, actually, it might report it as 0.000. A p-value cannot be 0. So remember, we're dealing with distributions. It's an asymptotic distribution. It never touches that 0 line. So if your p-value is reported as 0, what you're going to do is report it as p is less than 0.001. Because what that p-value probably is something like this. So it's a very, very, very teeny, 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 tiny number, but it is in fact not 0. So give your exact p-value. So T, degrees of freedom in parentheses, equals your T statistic, comma, P equals your p-value, comma, Cohens D equals whatever that Cohens D calculator gave you. That's it. This is how you write up in APA style a one sample t-test. Okay, so if you want to take a break again, this is an excellent place to do so, but now we will do our independent samples t-test. So in independent samples t-test, again, you're going to have two different groups. In this data set, we have a quasi-experimental variable, so gender. We're not going to assign people to a gender of 1 or 2, right? So that's why we call it quasi-independent. So it's a quasi-variable. If we had flipped a coin, heads or tails, you know, some people go into a room, low stress room, others go into a high stress, that would in fact be an experimental variable. This is quasi, which kind of means, you know, fake. We're kind of doing the best that we can here. But anyway, an independent samples t-test. So again, we're comparing groups, we're comparing something against something else. In this case, an independent samples t-test is going to compare our males versus females on our dependent variable of arousal. So again, we need to do the same thing. We need to check our skew, we need to check our kurtosis, we need to check box plots. This video is already getting long, so I'm not going to do that right now. You can revisit some of the earlier weeks if you've forgotten how to do that. To do our t-test, analyze, compare means, independent samples t-test. And again, I already ran this earlier, so I'm just going to reset that real quick. Your test variable is your dependent variable, so that's going to be our arousal. Grouping variable is going to be whatever your independent is or your quasi-independent. That's gender. You have to define those levels, right? So over here you can see gender, we have 1s and we have 2s, so that's what we're testing. We're testing the 1s versus the 2s on psychological arousal. Of course, we know 1s represent females, 2 represent males. You can go to your variable view and look at that. You really don't have to do anything with the options, so you can just hit OK to get your results. So here are the results. Again, two different things. First, they're going to give you the group statistics, so the number of people in each group, your mean, your standard deviation, all of those good things. That next box down is what you want to pay attention to. This is your t-test, independent samples t-test. Now, a couple of different things here. First, we have Levine's test for equality of variances. So remember we were talking about some of those assumptions for t-tests. So we talked about how normality was 1. One of the assumptions for independent samples t-tests is that the groups have approximately similar variances. So hopefully you remember variance from our first few weeks or from our conceptual lecture before this one. You want both groups to have approximately equal variances. That's what these two boxes are telling you right here. So you have your F and your sig. This p-value, if it is less than 0.05, it means that your variances across the different groups are different. That is a bad thing. So if this p-value is less than 0.05, it means that you cannot assume equality of variance. So it sounds bad, it is bad, but there are statistical ways to get around it. So a rule to remember, if this first p-value, you have to make sure you're underneath Levine's test. If that p-value is less than 0.05, you cannot interpret this top line. Instead, you're going to interpret this bottom line here. So this is giving you two different variations on the test. One variation in which you have met the assumption, so this p-value would be greater than 0.05. One variation where you have not met that. And if it's less than 0.05, you have to interpret the equal variance is not assumed line here. So that's the difference there. Now, our p-value for our Levine's test is 0.126. That means that our groups are not different in their variances, so we can interpret this top line. From here on out, it's just like interpreting a one-sample t-test. We have our t-statistic. Again, it was calculated with the difference between groups over the difference within groups. Then using our degrees of freedom, which in this case it's going to be n-1 plus n-1, so 19 plus 19 is 38. Using this information, we can calculate our exact p-value. So again, sig is our p-value. So you have to look at this number, ask yourself, is this number less than 0.05? If the answer is yes, our groups are different. So if that is less than 0.05, you reject the null hypothesis. The null hypothesis would be that males and females had similar arousal scores. If our alternative hypothesis would be that they're different, right? So P is less than 0.05. We can reject the null hypothesis that they are the same, and we can conclude one group was higher than the other, right? So you go back up to this group statistics box. Males had a mean of 24, females had a mean of 18.55. So in this case, you know they're different, and you know that males had higher psychological arousal scores than females did. Okay, so we know that they are different because our p-value is less than 0.05. We know that males scored higher. How different are these groups though? So remember, a p-value only says yes or no, they are different. Effect size is what's going to tell us how different they are. For t-tests, again, I would like for you to focus on Cohens D, and let's go to that website again real quick. So again, if you Google Cohens D get this calculator, you just enter in group 1 mean, group 1 standard deviation, group 2 mean, group 2 standard deviation, hit compute, and it will calculate your Cohens D for you so that you don't have to do that. So in this case, our Cohens D is 0.69. So it's a smaller effect than last time, but still, if you look at the effect size conventions in your textbook, this is a decent effect. This is something that we could publish. So we want to publish this. We have to write it up in APA style. Let's look at that now. Here is the write-up that I did for an independent samples t-test. So remember, these follow the results section in APA follow a very specific formula. So the first thing you want to do is say the test that you conducted and why you conducted it. So here, an independent samples t-test was conducted to compare psychological arousal by gender. Now the next thing we want to do is talk about our assumptions, right? So remember, if you were doing this in the real world, you might go a little bit more in depth into those assumptions. But for our cases here, I'm happy if you just report Levine's test. Remember, Levine's test is going to tell us if the variances across our two groups are approximately equal, because they need to be for this test, or we have to do some statistical magic to accommodate that special data situation. So we say Levine's test for equality of variances showed no violations, comma, p space equals, and then give that exact p-value. So remember, if you do have a violation, it's okay. You just interpret that second row there, that second row of results. If you can assume equality of variances, if your p for Levine's test is greater than 0.05, you stick with that top line. Whichever one you report, you want to make sure and tell your readers that. So you say, you showed no violations, p equals, so on and so forth. Next, results indicate that males, so males, that was one of our groups. In parentheses, you're going to give the mean and the standard deviation. Reported higher arousal levels than females. Again, their group mean, their group standard deviation, comma, t, in parentheses are degrees of freedom, equals the actual t statistic, which in this case was 2.20, comma, p equals 0.034, comma, looks like I accidentally put a period there. Let me fix that real quick. So p-value equals, comma, Cohens D equals 0.69. This is how you write up an independent samples t-test in APA style. So the test and why you did it, something about your assumptions. So in this case, I want you to report Levine's test. You should, of course, look at your skew, your kurtosis, your box plots, which we've already done here. But for example, when you're doing your midterm, make sure that you double check those just in case you do have errors. Even though I didn't report them here, you want to take a look at that. After your assumptions, you give your overall results. You'll give your mean and standard deviation for both groups. So in this case, we had a group of males. Here's their data. We have our female group, here's their data, and then we give the overall statistical information from that t-test that tells us, yes, they were different, so we know that from our p-value. We know how different they were because we have reported our effect size, Cohens D, as we should. So to summarize, we have t-tests. In general, t-tests are telling us, is this thing, this sample mean, different from some other group? In the case of a one sample t-test, you're comparing your sample mean versus a population. In the case of an independent samples t-test, you have two groups. So you flip a coin and you get, you assign heads to one group, tails to another group. You can run an independent samples t-test to see if those two groups are different. That would be an actual experimental variable. Here in this example, we're using a quasi-independent variable because, of course, you can't assign people to gender. So we have one sample, we have independent samples t-tests. The calculation of these, again, is looking at the difference between groups, controlling for the difference within. If you have questions about that or anything else, please comment here, send me an email, let me know, and we can help you figure this out.